Hi, this is Dharni from Department of Information Technology, Dr. N.G.P Arts and Science College. So I welcome you for this session. So in this video, we are going to see about some of the basic concepts of data structures, and one of the important data structure, that is a stack. Okay, we are going to see about the important concepts that are involved in stacks, what are the stack operations, and what are the applications of stacks. Okay, so when we are speaking about the application of stack, the stack is used in a wide range. Okay, but we are in this video we are going to discuss about one of its application. And to begin with the video, we will just see what is the data structure. So data structure is a way of organizing the data in the memory. Okay, so this organizing or the structuring the data, where it's plays a major role is based or depend on the application we are getting. Okay, so since you just consider you are working in an IT company, okay, you were given with a project. Okay, they told all the scenarios that they want in the application. Okay, so based on the working of the application and what are the operations that are involved in the application, you have to choose the data structure. Okay, so that data structure, it should be more efficient one. So in the efficient one, on that context, what we are speaking is efficient one is nothing but we want to access the data more easily through some programming languages. Okay, so data structure is a particular way of organizing the data in the computer so that it can be used effectively. Okay, so depending on what application you are getting, or depending upon what scenario you are getting, you have to choose the data structure. And there are a number of data structures that are available in computer field. And to be well clear about data structure, so I have given one real-time application of data structure. So when we are seeing, structuring the data, we can see in our real life. Okay, each and everywhere we are seeing this structuring concept. So one of the example or real time is grocery stores. Okay, so when you can, many of you have gone to the grocery stores, right? So in the grocery store, you can see that all the products will be arranged in a particular manner so that the customers can easily go and take what are the things they are needed. Okay, similarly, the same concept we are applying in the computer field also. So here where we are applying is we are applying it in the memory. Okay, so we are going to store the data in such a way that the application has to process it more efficiently. So that is the concept behind data structures. So there are a number of data structure. As I have already told, there are number of data structures that are available. So we can now see what are the basic classifications of data structure. So the data structure on its base, it can be classified into two types. One is primitive data structure and another one is non-primitive data structure. So primitive data structures are nothing but integer, float, character, and pointers. And the non-primitive data structures are arrays, linked lists, so list, and files. So this list, it can be divided into linear and non-linear. So linear, it comes stacks and queues, and in non-linear we will see about graphs and trees. Now we are going to deal with stack. Okay, so in the classification we have seen the stack, it comes under linear data structure. So what is a stack? What is the use of the stack? So the primary scenario, so when as a computer science student, when you got this word stack, the first thing that comes in your mind is last in first out. Okay, the stack is a data structure which follows last in first out manner, which means that the data or uh, the value which is placed last inside the stack will be taken out first. That is the basic operation of stack. So it follows LIFO order. Usually it will be represented as LIFO, that is last in first out. So the last thing we added is fetched out first. So the stack, when you are speaking about stack, you can access only one data at a time. Okay, so when you are taking a value, you cannot take more than one value from a stack. You can access only one value at a time. Now we will see some of the real-time examples of stack. So these are, you can see a stack of trays or a coin and the stack of shoe boxes. So in all these things you can note the data, the thing which is placed at the end, okay, will be taken out first. So this is the normal or simple real-time example of stacks. Next, we will see what are the operations that are present in stack. Okay, so usually the two basic operations that are present in stack is push and pop. Okay, so this push operation, it is nothing but the insertion operation. Okay, if we are trying to insert a data inside a stack, means it is called as push operation. Okay, and if you are trying to delete a data, or if you want to take out a value from the stack, means it is called as pop operation. So these are the two main basic operations that are executed in the stacks. Okay, so now let us see the stack operation with one example. So you consider this. So this is my stack. So you can see the size of the stack, that is 1, 2, 3, 4, 5. So my size of the stack is 5. So when we are operating with the stack, okay, the size plays a major role. So you can see the size of the stack is 5. So at most I can store only 5 elements. I cannot store 6 elements, right? So you can see, so this is my first position. This is my second one. Sorry, this is the third one, and this is the fourth one, and the last one will be the fifth one. Okay, so these are the positions of the stack. So now initially, okay, so in which position I want to place the data. So first data will be stored in the first position. This is the position where the first data will be stored. So for representing that position, we use a special pointer called a top pointer. Okay, so the top pointer is used to point the location in the stack. So you consider I want to include, or I want to insert a value 10 inside stack. Okay, I want to insert the value 10. So first I want to fetch the value of top. Okay, now my top is representing to the first empty location. Okay, so in this position I will include my value 10. Okay, so next I want to include the value 20 inside the stack. So for that purpose, I know with the help of the pointer only, I can, this pointer, top pointer only, I can include the values. Okay, so the first thing, if I want to insert the second, that is the next value, means the first thing what I want to do is I want to update my top pointer. So how can I update this one? Now I am just making the top pointer to point to the next location in the stack. Okay, so now I want to include the value 20. So now using with the help of the stop pointer, I will include the value 20 inside the stack. And next, similarly, the same thing will be continued. Now for example, if I want to update the stack with the value 30, okay, after 20 I want to add 30. So what is my first process? I want to update the stack pointer, which is nothing but I'm going to increment it by 1. So you can see here, so this is 1, 2, 3. So one basic algorithm, if you want to write an algorithm, means you just you want to increment the stack pointer, right? So now I'm incrementing my stack pointer and I am inserting the final value 30. Okay, so this is this three operations. So if you are trying to insert a value inside a stack, means that is called as push operation. So now we did 3 push operation in our stack. Okay, so now let us continue with the next operation, that is pop operation. So pop operation is nothing but we are going to delete one data from the stack. So for example, from this one you can tell me which data I can delete. Okay, so I told that with the top pointer only we can access the data. Okay, now my top pointer is pointing to the value 30. So if I want to delete a value, means I can delete only the value 30. And the next thing here you have you want to note, the another thing is you can see that 30 is the last element which we have included in the stack, right? So first we have included the value 20, 10, then 20, then finally we included 30. So when we are deleting any value, deleting one value from the stack, means we are going to delete the value which was inserted last. So we are following last and first out operation. Okay, so now I'm going to do the pop operation. So for doing pop operation, I can delete only the value 30. Okay, so now I'm deleting this value 30. So now I have deleted. So the next thing is I want to update my top pointer, because the top pointer, it cannot point to the some random memory location, right? So what I'm going to do is I'm just deleting that value and I'm decrementing the top pointer. So now the top pointer pointing to the last element in the stack. Okay, so this is called as pop operation. So this is how you can delete the value from the stack. Okay, so during push operation, you have to keep two things in mind. Okay, first you want to update the top pointer, then you have to insert the data. During pop operation, you just want to delete the data and you want to decrement the top pointer. Okay, for push operation, you want to increment the top pointer, and for pop operation, you want to decrement the top pointer. Okay, so these are the two basic operations that usually done in the stack. Okay, so next we will see what are the conditions to be checked during the insertion, that is nothing but pop operation or the push operation. Okay, so first we will see what is overflow. Okay, overflow. So you just we will first talk in the layman terms. Okay, so what is overflow? You consider one tank. Okay, one water tank. Okay, so its capacity is 100 liters of water. Okay, it can hold only 100 liters of water. If I'm just filling it with 101 liters of water, means what it will do? Just it gets overflow, right? So the same concept we are applying in stack also. So if the size of the stack, okay, here for overflow condition, we want to check the size of the stack. Okay, suppose in this example you can see my stack size will be 6. Okay, so 6 is my stack size and I'm inserting the value. So here you can see I have mentioned the position of the stack from 0. Okay, so I'm inserting, I have already inserted 5 elements. Okay, and the sixth element 60 I have inserted. Okay, so now my stack is full, right? In this case my stack is full. Now I'm trying to insert another value 70. If I try to insert another value 70, it will lead to overflow condition. Okay, because what is overflow? The size of the stack is 6 and now I am trying to insert the 7th value. So there is no room for that value. Okay, so this condition is called as overflow. So whenever we are doing push operation in the stack, we want to check for overflow condition. Okay, so this is one of the best example for overflow. And next, underflow condition, when we are talking about pop operation. Okay, so push operation we are checking for overflow condition, and for the pop operation we want to check for underflow condition. So underflow condition is nothing but, you can see this example. So now the size of the stack is 4 and I am having 4 elements in my stack. Now I am doing a pop operation. So when I am doing pop operation, the top value, the value which was inserted last will be deleted first. So 96 will be deleted. Then again I am doing pop operation. So the value 10 will be deleted. Again I am doing pop. So 48 will be deleted. And finally I am doing pop operation. 25 will be deleted. So I have deleted all the 4 values in my stack. Now my stack is empty. Now again if I try to do another pop operation, which will lead to underflow, because there is no value in my stack. Okay, and in this situation if I am trying to do the pop operation, means it will lead to underflow condition. Okay, so for overflow we want to check in the push operation, and underflow condition should be checked in the pop operation. Okay, so overflow, it is nothing but if the array or if the stack is full, means, and if we are trying to add another element which leads to overflow. Underflow is nothing but if the stack is empty and if we are trying to do the deletion operation, means it is called as underflow, right? So this is the algorithm. It's a simple algorithm which is used for stack insertion. That is nothing but push operation. Okay. So before inserting, you can see over here. Before inserting the element, I am checking whether top equal to max. Okay. So you can from this algorithm, I will tell you. So A is nothing but the stack. Okay. It is having some element in the stack, and top is the top pointer which is used in the stack A, and item is the element which we need to insert inside the stack, and maximum max is nothing but the size of the stack. Okay, so if top is equal to max means if there is no room for the element, or if there is no space for the element to be inserted means, then it will print stack overflow and it will exit. Else, that is if there is any room for that is if stack is not full means, the first thing what we want to do, we want to increment the top pointer. So I have incremented the top pointer, and in that position I have included the element, and then I will exit the algorithm. So this is the simple algorithm that is used for push operation. Okay, that is nothing but inserting the element inside the stack. And the next algorithm is the pop algorithm. Okay, so here also the same thing. The stack, I'm just giving the stack and the top pointer and the item as the parameter for this deletion algorithm. Okay, now I'm checking first in the insertion operation. I have checked for overflow condition. So here I'm checking for underflow condition. So if top equal to 0, which means that the stack is empty. So if stack, first thing I'm checking whether top is equal to 0. If it is equal to 0 means I will print stack underflow and I will exit. Otherwise, what I will do, I will store the element in the element that is in the top. I am storing that in the variable called item, and then I am decrementing the value of the top. Okay. So, and after that, I am exiting from the algorithm. Okay. So, this is the simplest algorithm for deletion operation. Okay. So, for insertion, before inserting operation, you should check for overflow, and for deletion, before deleting an element, you should check for underflow conditions. So now we will see the application of stack. Okay, so the application of stack, that is the stack, it can be used in a wide range. Okay, for example, if we want to try, if you want to check whether the string is a palindrome or not, you know what is a palindrome, right? So palindrome is nothing but if you are reversing a string, it should be same as that of the host string, right? So that is called as palindrome. So for that application, we are using a stack, and the stack, it is used to convert the expressions. Okay, so for conversion means it is used to convert the expression, that is infix to postfix or prefix, and then it is also used to evaluate the expressions, and then for syntax checking, for many it is having the applications in many fields. So in that one, we are now going to see how the stack can be used in solving the expression. Okay, that is nothing but how we can evaluate an expression using stack. Okay, so here before going into that one, you have to be clear about three types of expression. One is infix, postfix, and prefix. So infix is nothing but the root or the operator. It will be between the operands. Okay, so the representation, usual representation of infix is operands, operator, and then the operand. Okay, so the operator should between the operands. This is called as infix. Postfix means usually the operator will be at the end. Okay, first you will define the operands and then the operator. For example, if you are having you know that this is, you consider this as an operator. Okay, I'm having plus as an operator, and I'm having operands. Okay, p1 p1 and p2. So these are my two operands. If this plus is placed between, for example, 3 plus 2, if this operator is placed between the operand means it is called as infix. Okay, if it is placed after the operands, for example, p1, p2, then I am giving plus. Okay, so my operator is placed after the operands, so this is called as postfix expression. So this is the infix normal expression which we can understand, and this is a postfix representation of this expression. So here you can see that operands will be at the end, sorry, operators will be at the end, and the prefix is nothing but we are placing the operator at the beginning, okay, and then we will specify the operands. So here two operands are P1 and P2, okay, right, P1 and P2. So before going into the expression evaluation, you should be clear about this one, okay. So now we will see how an so this is one of the example for the postfix expression, okay. So you consider this postfix expression and we are going to evaluate this expression. So here we just consider the stack size as 6. Okay. So now I'm going to evaluate this expression using a stack. Okay. So initially the stack pointer, it will point to the first position. Okay. That is an 0th position. So now I'm going to trace or traverse this expression from left to right. Okay. So if it is an operand means I'm going to push it inside the stack. If it is an operator means I am doing the pop operation and I will do the calculations. Okay. So first is an operand. So the value 2 will be inserted inside the stack. Okay. And then I'm going to trace the next one. So the next is also an operand. So what I'm going to do, I'm just increment the top pointer and I'm going to point out to the next location and inserting the value 3 in the stack. And again I'm start scanning. So it is an operand. So I'm inserting the value inside the stack. Okay, I'm incrementing this value top pointer and then I'm inserting the value. Okay, so now the next element will be an operator. See here it is a star which indicates the multiplication operator. So when I'm encountered an operator, what I'm going to do is I'm just going to pop out the first top two elements. Okay, I'm going to pop out top two elements. So the value 1 and 3 will be popped. Okay, the value 1 and 3 will be popped. So you consider I'm going to store it in some variables. Okay, so let it be the variable B and let it be the variable A. Okay, so how I'm going to do this operation multiplication? It is nothing but I'm going to implement that operation between A and B. That is nothing but A, then the operator, what operator we are popping out, okay, the operator and then the operand B. So now here the value of A is 3 and what about the operator, what operator we have encountered, it is multiplication operator. So I am going to do multiplication and the value of B is 1. So 3 into 1, the value is 3. Okay, so the next step is I want to insert or push this value again inside the stack. Since I have popped out 3 and 1, my current stack position will be like this. I am having the element 2 and the top pointer will point to this element 2. Now what I want to do is I just want to increment the top pointer. Okay, I am incrementing the top pointer and inserting the value 3. Okay. Again, I'm going to continue my tracing. So after multiplication, I'm having another operator. So if it is an operator means what we want to do? We want to do the pop operation. Top two values should be popped out. So here 3, okay, the two elements are, the values are 3 and 2, right? And now I want to do the operation between this 3 and 2. It is nothing but plus operation, addition operation, and the result will be 5. So after getting the result, this result should be inserted, pushed inside the stack. Okay, so this is my stack and already there are no elements because I have popped out both the elements. So now the stack is empty. So the result of this operation, that is 5, will be pushed inside the stack. Okay, then the next one is the operand. It is 9. So what I have, what is the first step now? Here now currently the top pointer will point out to 5. So first thing is I want to increment the top pointer. Okay, now I want to make this top pointer to point to this location, and then I want to insert the value 9. Okay, then finally minus. So minus is an operator. So operator means I want to pop out these two values. Okay, top two values will be popped out. So when it is popped out, you can see how to apply the operator. So it is nothing but 5 minus 9. So the result will be minus 4. And this result should be again pushed inside the stack. Okay. So it will push inside the stack. So now the value 4 will be pushed inside this one. And it will check out the expression. Sorry, minus 4. It will check the expression now. We have reached the end of the expression. So what it will do? It will pop the last value out, and this will be the final result of the expression. Okay. So this is how the expression will be evaluated using stacks. And we came to the end of our session. So in this video, we have discussed about the data structures. That is the basic, what is a data structure and what are the different types of data structure. In that one, we picked out stack, and we have seen the basic concept of stack and what are the operations that can be applied on the stack, and finally the one of the application of the stack. Okay. Thank you very much for watching the video.